Okay, so this is the OCR C2 2006 paper. Question 1. The 20th term of an arithmetic progression is 10 and the 50th term is 70. Find the first term and the common difference. Also, we know that for the 20th term, a plus 19d equals 10. And then for the 50th term, a plus 49d equals 70. So we have simultaneous equations, so we can say a equals 10 minus 19d. So 10 minus 19d plus 49d equals 70. So then you can say that 30d equals 60, so d equals 2. Then you plug that back in, so a equals 10 minus 19d, which is 10 minus 38, which is minus 28. So your first term a is minus 28, and your second term, your common difference d is 2. In part 2, show that the sum of the first 29 terms is 0, so the sum equals n, which is 29, over 2 plus 2 times the first term, which is minus 28, plus, and then n minus 1, which is 29 minus 1, times the common difference, which gets you 0. Okay, the triangle ABC has AB equals 10 centimeters, BC equals 7 centimeters, and B equals 80 degrees. So we know that it looks something like this. And this is 10 centimeters, and this is 80 degrees. So find the area of the triangle. We just use half AB sine C, where A and B are the two sides next to the angle. So it's a half times 10 times 7 times sine 80. Make sure your calculator is in degrees, and that should get you 34.5 centimeters squared to 3 significant figures. Okay, the length of CA, we can use this by using the cos rule. So you know that CA will equal square root, and then it's going to be 10 squared plus 7 squared minus 2 times 10 times 7 times cos 80, which equals 11.2 centimeters. Okay, now part 3, find the size of the angle C. So we know that it looks something like this. This is 11 centimeters, 11.2. This is 7, 10. We know that this degrees is 80. So we can say that sine C over 10 equals sine 80 over 11.2. So then you can get C equals sine minus 1, 10 sine 80 over 11.2, which will get you 61.9 degrees. Here's question 3. Find the first 3 times of the expansion in ascending powers of x of 1 minus 2x to the power of 12. Well, the first term is going to be 1 to the power of 12, and then it's going to be plus, and then it's going to be 12 C1 times 1 to the power of 11 times minus 2x to the power of 1, plus it's going to be 12 C2 times 1 to the power of 10 times minus 2 to the power of 2, and that equals 1 plus 12 times 1 times minus 2 plus 66 times 1 times 4x squared, which gets you 1 minus 24x plus 264x squared. Hence, find the x squared coefficient in the expansion of 1 plus 3x, 1 minus 2x to the power of 12. So because this is 1 plus 3x, the only values we need to worry about are the x squared and the x value. So 1 minus 24x plus 264x squared. Okay, and you know that when we expand it, that the only values that will be x squared is 1 times 264x squared and 3x times minus 24x, which equals 192x squared. So the coefficient is 192. Okay, so question 4, the diagram shows the sector OAB with circle with center 0. The angle AOB is 1.8 radians. The points C and D lie on OA and OB respectively. This is given that OA equals OB, which equals 20 centimeters, and OC and OD equals 15 centimeters. So this is 15 centimeters, 5 centimeters. The shaded region bound by the arcs AB and CD by the lines CA and DB. Alright, so find the perimeter of the shaded region. So that means you want to find this line, and then these two lines, and then this arc right there. I hope that's clear. So you know that the length of this arc here is going to be 15 times 1.8. The length of this arc here is going to be 20 times 1.8. You know that these two are 5 centimeters each. So the answer is 15 times 1.8 plus 20 times 1.8 plus 5, which is 73 centimeters. Part 2, find the area of the shaded region. So we're going to find the area of the whole thing, the whole arc, and then take away the arc with radius 15 centimeters. So of course the equation for area of an arc is a half r squared theta, which is in radians. So it's going to be a half times 20 squared times 1.8 minus a half times 15 squared times 1.8, which is going to be 157.5 centimeters squared. Question 5. In a geometric progression, the first time is 5 and the second time is 4.8. Show that the sum to infinity is 125. Okay, so the common difference is going to be 4.8, which is the second term, over the first term, which is 0.96. So in the sum to infinity, it's going to be the first term over 1 minus the common ratio, which is 5 over 0.04, which equals 125. Okay, so part 2, the sum of the first n terms is greater than 124. Show that 0.96 to the power of n is greater than is less than 0.008, and use logarithms to calculate the smallest possible value of n. The sum of n is going to be the first term, which is 5, times 1 minus the common ratio, which is 0.96, to the power of n over 1 minus 0.96. The sum of the first n terms is greater than 124, so you can say that s of n is greater than 124. So therefore, you can say that 1 over. So then you can say that 5 times 1 minus 0.96 to the power of n over 1 minus 0.96 is greater than 124. And then you can rearrange that to say 1 minus 0.96 to the power of n is greater than 0.992. So therefore 0.08 is greater than 0.96 to the power of n. And then use logarithms to calculate the smallest possible value of n. So log 0.96 to the power of n is going to be less than log 0.008. Then you can write this as n log 0.96 is less than log 0.008. Then n is going to be, of course, you flip the sign, log 0.008 over log 0.96. So you get n is greater than roughly 118.3. So the smallest value of n is going to be 119. Okay, question 6a. Find the integral of x to the power of a half plus 4 with respect to x. So we're going to add 1 to the power, which is x to the power of 3 over 2, and then divide the coefficient by that power. So 1 divided by 3 over 2, which is 2/3, plus, and then we do the same thing, which is 4x, and then of course plus c. Okay, so find the value in terms of a of the integral with upper bound a, lower bound 1, of 4x to the minus 2 dx, where a is a constant greater than 1. Okay, so we're going to integrate 4x to the minus 2. So like I said, we up the power by 1, and then we divide the coefficient by the power, so it's minus 4x to the minus 1. And then of course we add in our boundaries, which is a and 1. So we can say that minus 4 over a minus 4. So then you can say 4 minus 4 over a. Okay, and introduce a value when the upper bound is infinity. So you know that, well, as we can say a tends to infinity, that 4 over a tends to 0. So therefore the value is 4. Okay, question 7. This is just simple logs. So part A is just log base 10x minus log base 10y. Because when you minus 2 logs, they divide the inside of the brackets. And for part B, log base 10x squared y is going to be log base 10 plus, because here it's the product of these values, log base 10x squared plus log base 10y. And you know that log base 10 is just 1, and then this can be written as 2 log 10x because the power goes to the front, and then plus log 10y. Okay, so given that 2 log 10 x over y plus equals 1 plus log 10x squared y, find the value of y correct to 3 decimal places. So we can say that 2 log base 10x minus 2 log base 10y equals 1 plus 1, which is 2, plus 2 log 10x plus log 10y. We know that the 2 log 10x is cancelled out. And then we can rearrange to say that 3 log 10y equals minus 2. So log 10y equals minus 2 over 3. So y equals 10 to the power of minus 2 over 3, which is approximately 0.215. And we give that to 3 decimal places. Okay, so the cubic polynomial 2x cubed plus kx squared minus x plus 6 can be denoted by f of x. Is given that x plus 1 is a factor of f of x. Okay, so let's denote it as f of x. F of x equals 2x cubed plus kx squared minus x plus 6. So if x plus 1 is a factor, it means x equals minus 1 is a root. So that means f of minus 1 equals 0. So we can plug these values in. So 2 to the minus 1 cubed plus k to the minus 1 squared minus minus 1 plus 6 equals 0. So then we can get k plus 5 equals 0, k equals minus 5. Find the integral of f of x with respect to x and upper bound 2 and lower bound minus 1. So the integral of 2x cubed minus 5x squared minus x plus 6, upper bound 2, lower bound minus 1, with respect to x. So we're going to just use the power rule. So x cubed, we add the power x to the power 4, and then divide the coefficient by the power. So we get a half x to the power 4, then repeat this, so minus 5 over 3x cubed minus a half x squared plus 6x. And then of course, upper bound 2, lower bound minus 1. Okay, so when I plug in 2 into this, I get 14 over 3. And then when I plug in minus 1, so I take away the lower bound. When I plug in minus 1, I get minus 13 over 3. So that equals 27 over 3, which equals 9, which is your answer. Explain with the aid of a sketch why the answer to part II does not give the area of the region between the curve y equals f of x and the x-axis. Well, if we draw f of x, it is an x cubed graph with the y-intercept of 6, so it crosses like this. And between x equals minus 1 and x equals 2, part of it is below the x-axis. So part of the area is below the x-axis, so the area cancels out. So you say what I said, and then just the area cancels out as well. Question 9. Sketch on a single diagram showing values of x from minus 180 degrees to 180 degrees. The graph of y equals tan x and y equals 4 cos x. Okay, so we know the y equals tan x graph, and we know the y equals cos x graph. Y equals 4 cos x is just the y equals cos x graph with a stretch of scale factor 4 parallel to the y-axis. So we can draw it here, just a sketch. So let's call this minus 180 degrees, minus 90 degrees, 90 degrees, and 180 degrees. So of course, the tan, y equals tan x, does not touch the 90 degrees, so it will go like this through the origin, and then back up, and then there'll be another graph like this, another line like this. So blue is y equals tan x. Okay, and then in red, we'll do the cos x graph, and because it's a sketch, we can just draw the normal cos x graph, which will look something like, well, it'll be its minimum minus 180 degrees, and then go to 0 minus 90 degrees, and then go to its maximum, and go back to its 0, and then a minimum like this. And then, of course, it is a sketch, so you have to point the parts where they intersect. So here, it's going to be 4, and then here it's just the origin. Okay, the equation tan x equals 4 cos x has two roots in the interval minus 180 degrees. Sorry, x is equal to more than minus 180 degrees and equal to less than 180 degrees, which are denoted by alpha and beta, where alpha is less than beta. Alright, so the two roots of that equation is going to be the 2 points where the two lines meet, the y equals tan x and y equals 4 cos x. So that is here and here. And they said alpha is less than beta. So this one here is going to be alpha, this one's going to be beta. And express beta in terms of alpha. Okay, so well, the y value of alpha and beta are the same, the modulus of those values. And then if you think about a tan cast diagram, beta is going to equal 180 minus alpha. To work this out, you just kind of have to use your knowledge of tan graphs and cos graphs. Part 3, show that the equation tan x equals 4 cos x may be written as 4 sine squared x plus 4x minus 4. Hence find the value of b minus alpha correct to the nearest degree. Okay, so tan x equals 4 cos x. And of course tan x is sine x over cos x. So you can say that equals 4 cos x. So you can say sine x equals 4 cos squared x. We know that cos squared x plus sine squared x equals 1. So you know that sine x equals 4 times 1 minus sine squared x. So this can be written as 4 sine squared x plus sine x minus 4 equals 0. Okay, then next we can let u equals sine x. So we can write this as 4u squared plus u minus 4 equals 0. Then we can use the quadratic formula to get u equals minus 1 plus or minus square root 65 over 8. So sine x equals minus 1 plus or minus square root 65 over 8. Therefore, beta minus alpha equals beta minus alpha equals 118.2 minus 61.97. 118.02, I'm pretty sure that was, which is 56 degrees to 2 significant figures. I hope that helped. Please leave a comment if anything was confusing, and I'll go over it in a separate video. And like if you find the video helpful.